Welcome back for my new video on the chemistry on the polarity of the molecule. So basically I'm Dr. Hussein bin Haniba, so that's my Instagram, you can have a look. So in this video we're going to discuss about the electronegativity and electronegativity and polarity of the bond and polar and non-polar molecule. Please keep in mind this discussion will be limited for a simple molecule, covalent molecules only. So without further ado, we will proceed with it. This is our learning outcome, that we were going to classify a molecule, a covalent molecule, into a non-polar, polar or ionic based on different in electronegativity of the atom in a molecule. So basically, please remember, we are going to talk about polarity of a molecule. It's very much depends on the electronegativity of the element. So we will explain a molecule as a polar and non-polar based on the molecule shapes and dipole movement. I will discuss about the dipole moment in a short while after this. So let's discuss. We will limit our discussions again. Let's refresh back what we have learned so far. So covalent bond basically can be divided to a polar covalent bond and a non-polar covalent bond. Of course, the last will be coordinate covalent bond, dative covalent bond. Those are the topics that we will cover over here. So let's start. What do I mean by a polar covalent bond? Polar covalent bond. Remember, it is actually a covalent bond. Definitely it is a covalent bond. It is made of, as example over here, it is made of a non-metal and also a non-metal element. Definitely it is made of both of this, but nevertheless, please keep in mind this combination of molecule is basically made of a different electronegativity elements. Yes, you can see over here, we have learned in the previous video, chlorine have a higher electronegativity as compared to hydrogen. Therefore, chlorine have a higher tendency to pull electron compared to hydrogen. Therefore, the more electronegative atom pull the shared electron closer to its side. What does this statement stand for? Again, let me refresh. More electronegative element, and it will pull the one to the side. Okay, it is general true at this particular one. It is a covalent bond made of sharing of electron. So ideally, this bond, it have a one electron over here and another electron over here. So this is for a very symmetric situation, but nevertheless, what happened? Chlorine have a higher tendency of electronegativity. That's why we call this as a partially negative charge. So what happened? This is partially negative charge. It have a higher tendency to pull this particular electron, closer to a chlorine side. Therefore, we found out this electron is attracted closer to the chlorine atom. So it have a higher tendency, chlorine have a higher tendency to pull electron from hydrogen. Okay, since it pull electron, this is less electronegative, so hydrogen is said as a partially positive charge. Why? It is because electron deficiency. Why there is electron deficiency? Because the electron that owned by hydrogen have been pulled to the chlorine side. That's the main thing you need to know. So this cause it's like chlorine have a higher tendency to pull the electron over here. It become non-symmetry anymore. The attraction force is not at the equilibrium point. So it is not at equilibrium. So what happened? The result will cause the attraction of the electron toward to the chlorine more. Therefore, there is an attraction force that cause between the hydrogen and chlorine. So it means the attraction is more toward to chlorine rather than the hydrogen. Therefore, this molecule is said not at a symmetric position. When this is not at the symmetric position, we call this as a polar bond, or more it's known as a polar molecule, polar covalent bond. Okay, I will give more example about this. Have a look the next slide. So please remember our electronegativity scale. When you are going toward to the right hand side, when you are going to the right hand side, the electronegativity increases. When you are going downward, the electronegativity decreases. Okay, so refer to the previous chapter that we have learned. So let's look about this, a classifications of bond by different electronegativity. So if let's say you calculate the difference in electronegativity. Okay, what do I mean by electronegativity? Go back to here. Okay, we know hydrogen have the electronegativity value and chlorine have electronegativity value. So what happened? You calculate the difference between the electronegativity value. For information, chlorine have a electronegativity around 3.5. Okay, so this is 3.5, and also hydrogen have the electronegativity value around 2.1. So guys, the difference in electronegativity between chlorine and hydrogen is will be 3.5 minus with 2.5, then you simply will get around this one. You will get 1.4. It is equivalent to the difference of these two is equivalent to 1.4. So guy, what this 1.4 tell us? Go back to this table. So we will find over here the differences. Do you notice or not? The differences. So just now we calculate for hydrogen and chlorine. The differences is falls between this range. Do you notice or not? The 1.4 is between this. Therefore, what type of bond do the hydrogen and chlorine have? It is called as a polar covalent bond. So the difference between the electronegativity value tell us the type of bond. So if you have a value more than 2, we call this as a ionic bond, and if you have a value equivalent to 0, that is labeled as a non-polar covalent bond. So I refresh again. So when you this is the sequence. You have a covalent bond, polar covalent bond, and of course again you have a covalent bond, polar covalent bond, and highest will be the ionic bond behavior. So increasing difference in electronegativity. So you have the bigger the electronegativity value, it falls on the difference category. So that is the reason some of the students do ask me, aluminium chloride. Aluminium chloride is a very classic examples. If you minus this electronegativity value, you will notice the value as actually falls in the regions of the covalent bond, polar covalent bond around that. That's why it's sharing the electron are the covalent bond compound because of the high polarizing power, high charge, and a small size. That's the reason. Those are the few exceptional case. Please take notes, guys. Aluminium chloride, barium chloride are covalent bond. It is not ionic bond. Because of why? Because of the difference in electronegativity. So few examples. Let's look this one guy at very classic examples. I have a chlorine and chlorine. Chlorine is around, the electronegativity of chlorine is 3. Just now I say 3.5. Okay, correct it over there. So when you minus this, you get a 0 value. So when you get a 0 value, it falls in the regions of a non-polar covalent bond. And this one, when you minus this 2, you falls under category of a, you get a 0.9. It is under polar covalent bond. And when you have a NaNCl, you minus the electronegativity value and you get around ionic bond range. Please have a look. So that's how you determine either a molecule is a polar or non-polar or ionic bond according to the difference in electronegativity value. So let's move to the next slide. Some checkpoint you can have a look. Classify each of the bond ionic or polar covalent or covalent bond. Remember, you must you can only determine this after you calculate the differences in the electronegativity value, such as for this one. So in order to do this, you must refer this to a electronegativity scale. So those are the answer. We know hydrogen is an iodine. The difference is 0.4, and 0.4 is falls under category of polar covalent bond. This one I'm actually answering this question by referring to this particular table. So you must know this in order to answer that sections. Okay, so between these two, let me refresh, I don't know why. Okay, we have this one and this one, so the difference is 3.2. It's more than 2, therefore it falls under category of ionic bond. Again, between 2.5, F is highly electronegative. Okay, that's the reason. 2 carbon, I'm referring to this one. This is the questions. So therefore the two carbon atoms, so identical, 2 carbon atom are identical, definitely the electronegativity value will be 0. Therefore it become a non-polar covalent bond. That's the answer. So let's move to the next sections to determine the polarity of molecular bond. So I will discuss this on my next slide, next video. Please stay tuned.